Hello, my little triglets. I want to start off our session today by having each and every one of you take a deep breath. Breathe in, breathe out. Now, did you know that graphs of the trig functions are used to analyze the breathing cycle of humans? Yes, trig shows up in many, many ways in all parts of our lives. Today we're going to talk about section 5.5, which is basically trig graphs. Okay, we're going to start off with our handy dandy sine function. And basically what I'm going to do is I'm going to take the circle and I'm going to take the corner points and use those to graph the sine function. Okay, so watch carefully. So if I have x as my input and sine of x is my output, which is another name for y, I should be able to graph on our line here. Now my y values aren't going to be lower than 1 or higher than, or lower than -1 or higher than +1. So I'm going to put those on right now. And my x values are going to be the angles that I choose. So the first one I'm going to choose is 0, then pi over 2, then pi, then 3 pi over 2, and 2 pi. So that's what I'm going to label on my x-axis. I'm going to start out here with 2 pi, cut it in half again, and then fill in the 3 pi over 2. All right, so let's plug in, and here's 0 here at the beginning. So 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are my x inputs on the x-axis, and let's see what we get on the output. So at 0 degrees, my sine is 0. At pi over 2, my sine is 1. At pi, my sine is 0. At 3 pi over 2, my sine is -1. And at 2 pi, we're back to 0. So let's plot those. 0, 0's here. Go over pi over 2 and up 1. Go over pi and up 0. 3 pi over 2 is -1. And 2 pi is back to 0. Let's put a nice smooth curve between those points, and voila, we have our graph of our sine function. Now if I continue to choose points here, I could do negatives, which would make the graph go in this direction. I could do higher points all the way up to 4 pi and beyond, and I would go here. So the next round would get us out to 4 pi. The next one would be 6 pi. So every 2 pi, I'm repeating the cycle. Okay, now let's do that same idea with cosine. So if I have x and cosine x, let's do it in blue here to differentiate. So I'm still going to pick 0, pi over 2, pi, 3 pi over 2, and 2 pi. Still going to have my grid here, still going to be 1, -1. 2 pi's out here, pi, cut it in half, and so on. All right, so this time 0, let's see, let me move up just a little bit. Right here's cosine, so at 0 degrees I have 1. And at pi over 2, my cosine is 0. At pi, my cosine is -1. At 3 pi over 2, my cosine is 0. And at 2 pi, we're back to being at 1. So the first point is 0, 1. That would be here. Then pi over 2, 0 would be here. Then pi would be -1. 3 pi over 2 here and here. So I have another smooth curve. All right, again, I can go in this direction or I can go in this direction if I keep going or if I go negative. Now, if you look at the main portion of the graph that we did first, from here to here, that looks like the letter S, and that's your sine wave. If you look at it down here, that's the C, so that's your cosine wave. So that's one way you can differentiate. Okay, I want to do one little thing here before we move off of this page. I'm going to add, actually I'm going to do it with the cosine. I'm going to add a third column here. I'm going to add 3 cosine x and see what happens. So all I'm going to do is take 3 times this value. So 3 times 1, 3 times 0, 3 times, whoa, beautiful 3. Negative 1, 3 times 0, and 3 times 1. So graphing on the same grid here, if I put in a 0, I'm going to get out a 3. So 0, 3 is right here. Then 3, 0, I'm sorry, pi over 2, 0 would be here. Then I have pi and negative 3, so I need to go down to negative 3. 3 pi over 2 is back to 0, and 2 pi would be back up to 3. So putting a smooth curve through that shows what happens when you multiply one of the waves by a number in front. It basically stretches the graph up and down. Now in Trig, there's lots of these changes. That's just one of them. There's about 5. So we're going to list those right now. So I'm going to go to a new page, and we're going to start out with the basic everyday function. It goes y equals a sine, parentheses, bx minus c plus a d. Now each of these letters represents a change. There's 4 there. The other change is if you have a negative in front, it will flip the graph over. So for an example, pi, 2 pi. If you have your normal sine wave, then the flip would be like this. It just is upside down. Okay, the A stands for the amplitude. And I just showed that with the previous drawing. Let's go back. This is the A part. It's in front of the word cosine. So that's going to stretch vertically. Okay. And it also actually could shrink it too. If it's a very small number, it could squish it down below 1. The B represents the period, or another name for the wavelength. Right now, our normal wavelength is 2 pi, but it could squish like an accordion. Okay, so we could think of this as the accordion stretch or shrink. Accordion, stretch or shrink side to side or sideways or horizontally, however you want to say it. There's a little formula with this, and it's 2 pi normal wavelength divided by b, which will give us our new wavelength. The C is called the phase shift. And that basically is a slide right, which would be a negative sign, or left, which is positive. Now I know that's backwards of what you think, but it's in parentheses here with a minus sign. Just like in parabolas and other graphs you've done, inside the parentheses usually ends up being opposite of what you think. And D, our last but not least, is called the vertical shift. Shift meaning you slide up, which would be positive, this is normal, or down, which would be negative. Okay, so that it's outside the parentheses, it's normal. All right, so let's try one that involves all of these changes. Okay, so let's try. Start out in black. So y equals negative 2, whoops, let me back up here, equals negative 2 sine 2x minus pi plus 1. All right, so over on the left, we're going to write down everything we're going to do. We're going to flip the graph. Our amplitude is going to go to 2 and negative 2. The period, which is the wavelength, is going to be 2 pi over 2, which is your B. So it'll be pi. So our new wavelength is pi. our C, which is our phase shift, you take C over B. Now I don't think I wrote that in the previous part. Let's do that. So right here, I want you to put C over B because we have to make sure the B, if it's different, it affects the slide, left and right. So C over B, in our case, here's your C, 1 pi, not just 1, over B, which is 2. So that means I have to go pi over 2, and it's a negative sign, so we're going to go to the right. And then the vertical shift is just D. That means we're going to go up 1. Okay, so now we have to prepare our graph. All right, amplitude. I know I'm going to have to go up to 2 and down to -2. Then I'm going to check the D, because that affects the up and down, just like the amplitude. Well, if I need to go up 1, I have to make sure I include another step, at least one up from there. Okay, now I'm going to go and figure out my wavelength. Normally we would put 2 pi out here, but now I'm changing it to pi, which would make the halfway point pi over 2. And then you can just put little notches here to help with the graphing. Then I know I'm going to have to go pi over 2 to the right. So I'm going to add another notch here. I have to add pi over 2 to pi that's already there. So that's 1 or 2 halves pi plus 1/2 pi. So this should be 3 pi over 2 is where I'm going to end. So we're changing the labels to make it fit all these changes that are going to happen. All right. Now graphing it, it's hard to do all 4 changes at once, so I'm going to do a couple together. Like I'm going to do these 2 together. Actually, I'm going to include B in with that. And then I'm going to do C by itself and D by itself. Okay, I'm going to erase this little part here. I didn't mean to erase that much, gall darn it. So again, I'm going to write down amplitude is 2. And the period is 2 pi over 2. Okay, so flip, amplitude, and wavelength. Well, I've labeled most everything, so that will help. So the flip means, and it's sine, so it's the S shape. I can flip it, means go down instead of up, and come up and then down. You have to end at pi over, or end at pi, so you have to go through pi over 2. So I just did these 3 things all with one step. So that's the black graph. Now let's do the blue one here. So I'm going to take the black one and I'm going to move it over to the right, pi over 2. So what I like to do to make it easier is to put little dots at all these crucial points and move them pi over 2. So that goes here. This one goes to here, this one goes to here, and this one goes to here. So now I can connect those dots. Looks kind of cool. So all I did was slide the black one over to the right, pi over 2. Now our final graph is always going to be in red. So I'm going to take those blue dots that I just did on the blue graph and move them all up 1. All right. So I'm going to move this one up 1 to here, right there. This one goes up 1 to here. This one goes up to 3. This one goes up, and this one goes up. Whoops, I'm going to erase this one. That was a boo-boo. Okay. This one here is the blue dot I need to move up. All right, now see all the red dots? We're going to connect those and end up with the sine wave. Upside down, but the sine wave. So our final will always be in red, so we can find it easily, because you could have a lot of changes on here. All right, so we're going to do a little more of this in class tomorrow. If you can figure out all of this stuff on the left before you start graphing, it makes life a lot easier. Okay. All right, I'll see you in class tomorrow. Ta-ta for now. Don't forget about trig love.